What's up people, welcome to my tutorial in anomaly detection. So in the previous video we had a look at the isolation tree implementation, and one of the things that we discovered was that because of the data and how the data looked, specifically with the labeling, that it was a balanced data set. So you would have 50%, around 50% of the data as positive and 50% as negative, meaning that if you're using that as a measurement for your success, you're not going to have much success with that data set since the positive samples are not anomalies in the data. And so what I did instead here is I head over to Kaggle and look at this other type of data set that would be better. So I found this credit card data set here. I think they have taken all the attributes here and remarked the columns with anonymized data here, v1, v2, etc. And then you have like time left, and you also have the transaction amount and the class. So it does have a class, positive or negative, but if you look at this data here, I was a bit skeptical first if it was even classified, because you see here it's 284,000 negative samples, and I don't even know how many positive samples there are, but it's not at all as many. So this might be a good candidate to see, okay, is there anything in the V columns here that says has some correlation with the classes here, and that's what we're going to use here. So you can download this CSV file. I'm not going to include it in the source code here because I think it's kind of too big to include in the repository. But it's in the README file of the repository. You can find the link to this thing, or just Google it here. You can see the thing. So in the CSV sampler, I've done some modifications. I have implemented this credit card data thing, so it's reading in another CSV file, skipping another header here, parsing it a little bit differently with the B columns that you see here for simplicity. Otherwise, it's the same. I have done one additional change as well. I had to increase the subsampling size, because if I had 256 samples in the samples, I would run into problems, because since the unbalanced data looks like it does, it would not include any positive samples at all, because they're so infrequent. So if you have a small sample size, it's not going to be in there. So I increased the subsampling size a bit to adjust for that. And then I have ran it like this, the CSV sampler, and it's outputting it to the samples B file here. It's going to take a little bit more time because it's a bigger sampling. It's going to swapping a little bit more, and now I have 284 samples in that sample. So in the isolation forest, I've done some modifications also with what columns specifically should be used. So here I'm not using the diagnosis field as a label anymore. I'm using a field called class as a label, and I have also changed, let me go ahead and find it here, for the attributes, time amount class, and then the V columns. I'm going to use all of them. Otherwise it's identical. So now let's go ahead and have a look here what this thing does. So if now I run this thing again, I'm going to run it from the terminal this time. So isolation forest here. Then we're going to see some hopefully different results. I have set the threshold to be 0. Basically, I've set it to say that everything is positive here. And that's going to give it some characteristics that might be good to see, right? So the true positives here, that's only like 0.1%. And the reason why it's like this is because the data is unbalanced, right? So don't be fooled by the false, the very low rate of true positives. The reason why it is like that is because the data is not balanced. The false positives was really, really high, of course, because it believes that everything is positive. True negatives, there were none. False negatives, there is none. Sensitivity, as you know, sensitivity can be. But let's have a look at this thing here. Maybe we can find a good value here. So let's go ahead and see if we can find any credit card fraud. Let's start with 0.4. Let's see what that gives us. It's going to take some time to run here. It might even complain a bit now. Now we have bigger data set with the recursiveness. But okay, this looks a bit different. The sensitivity has definitely gone down. The specificity much higher. The precision is much higher. You need to consider all of this together because it's going to behave differently with an unbalanced data set. But the true positives, it managed to find some of them. And it missed some, and here for the false negatives, it missed some of them. So these are the two I think you should pay most attention to here because of the unbalance. So maybe we can live in this particular case with a little bit more false positives, just so we don't miss anything. So let's go ahead and lower that thing to 0.37 and see what that does. So you can, play around with the threshold here to see what's going on more. So so now it's a bit different here. We actually have no false negatives, meaning we didn't miss anything. And true positives, and sure, we had some false positives as well. But in this domain, I believe that it's probably better to be more generous with a lower threshold to actually find the things rather than, missing credit card fraudulent. And that might be true in your use case. It might be the quite opposite, that you just want to find something. So it depends on your use case is my point. Okay, cool. So that's going to give you a second opinion a little bit about how you should be using this algorithm, according to me at least. That's my personal opinion, I would say. But this is definitely one use case for it, and you can read the evaluation section of the paper to see more like detail of the performance of it. But it scales for large data sets because of the sampling and other characteristics with the early termination of the subtree and so on. So if you're interested more in the details, you can definitely read that. But if you're just interested in the implementation, you can skip it, according to me. That was everything I wanted to show in this video. Don't forget to subscribe, and I will see you in the next video.